fantastic math? Good. Okay. We need to start up where we left off. So where did we leave off? I think we left off around question 42, right? I think we did example 44 and then we went back to 42. Does that sound right? Because we learned proportionalities first, and then after we learned proportionalities, then we learned regular fractions. So I'll let you pick your favorite one. Pick your favorite one from 45 to 47, and then I'll show you that as the example. So 45, 46, or 47, I'll let you think about it for a little bit, and then somebody can pick one. 46. Okay, correct. Okay, by the way, Psalms 46. Does anybody know what Psalms is in the Bible? Psalms 46 is a nice psalm, so you should read Psalms 46 if you want to feel happy about it. But so the problem 46, unfortunately, is not as nice as Psalms 46. But it says 3 over 7x plus 35 equals 3 divided by x plus 5 minus 3 over 7. By the way, did you know in my other math class today that we learned how to solve problems with triple equal signs like that? So if you put a third line on it, that's called a congruence.
Are we gonna learn that eventually?
No, not in this class. You'll have to go into the other class to learn that, sadly. It's called discrete mathematics.
Nope.
That's weird.
I know, it is weird. So it's 3 over 7x plus 35 equals 3 divided by x plus 5 minus 3 over 7. And we have to solve this. So first of all, we can't solve it by cross multiplying because it's not just a proportionality with one fraction on each side. It has 3 total terms, not just 2. So I've got to play well, first I have to factor. Which denominator is not factored yet? Right. So the last ones, I can basically just pretend factor them just by putting parentheses around them. That's it. But the 7x plus 35 is not factored out because there's something that can be taken out from it, which is a 7. If I cross that out and replace it with 7 times x plus 5, now it's been factored. So then let's play the jealousy game. And what would you want to be jealous of if you saw these 3 different fractions and you looked in their denominators and you saw what they had? You'd be jealous of a 7, right? Because 2 of them have a 7. So now you have a 7, so you're not jealous of that anymore. What else would you be jealous of? Correct. And now you have anything that everybody else has, so now you're not jealous anymore. Well, actually, that's not quite true because in reality, jealousy is like a disease. And you can keep on being jealous of things. The Bible says the eye is never full. So like you'll just keep on seeing more things you want. At least I think it says that. That might be out of context, but
So we're gonna keep on going.
yeah, we're going to keep on going. Yep. So once you find the LCD, how do you solve equations that have little fractions within them, like on both sides, for example? By the way, I'm just rewriting it because I just have nothing better to do. Just kidding. I don't know why I wrote it, but okay, there. So for no reason, I just wrote it again. But I wanted to emphasize that we're going to take the 3 terms and put them in like groups. What are we going to put beside each term? The LCD, right? So I'm going to put that in pink, I guess. So 7 times x plus 5. 7 times x plus 5. By the way, what's the best color? Pink. Now I'm starting to think of if there really is a best color. Maybe it's white because white has all other colors in it. So maybe that's white. I don't know. So 7 and x plus 5 is beside everything. Can anybody tell me what to do next? Next, I need to start canceling. So we're going to be having the cancel culture right now. Not that kind of actually canceling, but so that cancels, that cancels, that cancels, that cancels, that cancels, that cancels, and then those other 2 things canceled. So the only thing that's left is 3 equals 3 times 7 minus 3 times x plus 5. Cool. That was so cool. Okay, it's hard to see the green ink, isn't it? Let me change to like black, because black is like more on track. There we go. If it doesn't rhyme, is it even worth saying? There we go. Okay, perfect. So now what do I do next? Simplify even more. So distribute to -3, -3x. -3 times 5 is -15. And then 3 times 7 is 21. And then equals 3, right? Perfect.
Wait, I have one more question.
Yeah.
How did you get that 7 on the last line? Go ahead and say everything else except how you got.
The 7.
Oh.
That's because, yeah, that's in the LCD, yep. Yep. And then how can I simplify even more? How about the 21, the 15? Are those like terms? Yes. So the 21 and the -15 can join together and make a brand new happy 6, right? 6 minus 3. Oops, I started to say 2 accidentally. My brain has too many things to think about. 6 has to think about the football game, like how happy we are about that. By the way, who would have predicted it would have been like a blowout like that? It's supposed to be like a close game, right?
I got cane though. Yeah.
Were you there?
It's all because of, yeah, it was all because of the supporters that were there. So I didn't help though. I had to get ready for my next day of work, but because I had to do like a photo shoot on Sunday for the basketball team. Okay, 3 equals 6 minus 3x. Now, okay, I guess there's no answer to problems like this. I heard somebody in the side on the sidewalk say that one time. So we can't solve this. Just kidding.
Well, that's an answer, right?
No,
Oh,
I was just kidding.
There's still more.
So what can I do to keep on solving though? We could subtract 6, yes. Good job. By the way, there was one math book that I thought was really funny, and it had cartoons in every chapter called Math on the Street. And it had like these boys talking about math, or whoever talking about math, like saying goofy things like, well, you can't divide by 0 because it'll make your eyeballs fall out. Things like that. But it was like partly true, like probably not true. So 3 minus 6 is -3. And then, so if you had math on the street, how would you solve this? You got to divide by -3. There we go. What's -3 divided by -3? 1 equals x. Wow, that was, oh wait. Before I go off and assume that that's the correct answer, how do you know for sure if it will really work or not?
Plug it in.
Plug it in. Okay, yes, that's correct. Although in theory, if as long as we didn't make any mistakes, it should work, except sometimes though, even if you didn't make any mistakes, it still doesn't work though. So let's just assume we did not make mistakes. How do we make sure it still works even if we didn't make mistakes? Well, okay, yeah, we have to make sure that we're not dividing by 0. Because remember, math on the street, if you divide by 0, your eyeballs will fall out. So I know it doesn't, it's not supposed to be. So if I plug in 1 into x, what's 1 plus 5? 6. So that's not 0. And the same thing if you plug into 1 plus 5, another one, that's also not 0. So this one is good to go. HOTTOGO, isn't there some? Okay, so 1 equals x, now we're good to go. Okay, any questions about that? So do you think you're confident in your ability to solve these problems? Well, if you can solve them, let me just explain to you what could happen sometimes. What happens if, okay, let me show you something real quick. What happens if you get I don't want to do like a whole nother entire problem, but what happens if you, okay, well, I'll let you do 47. If you choose 47, I can, no, wait. Not 47. Actually, 46, 47, and 45, nothing exciting happens in them, actually. So those will all work the same way as this one. So thankfully. But I guess I should still tell you anyway, though. What happens if you get an equation like this at the end, like 4 equals 4? What if you get that at the end? Then you have to say infinitely many solutions, right? And then what if you get an equation at the end that says like 4 equals 3? Then what do you say? No solutions, right? By the way, what does solves, infinity many solve? That means solutions. Okay. So let's go ahead to another one. Let's do a word problem because the word problems are sort of difficult. This one is going to be exciting. So they should teach about this problem in chapel, actually. So 48 says the function f of x equals 360x divided by 100 minus x. And this is a special function that explains how much the cost is in millions of dollars to remove the pollution from a river. So this is the cost of removing pollution, of removing X percentage of the pollution, X percent of a river's pollution. So first of all, is there any pollution in the river? Do you think? Yeah, because anytime you throw something nasty into it, it gets polluted. How much would it cost to remove a certain percentage of the pollution that's in it? So let's say if you removed zero pollution, how much would that cost? $0, because if you plugged in 0, you'd have 360 times 0 divided by 100, which is 0. Okay, so how much would it cost to remove how many million dollars would it cost to remove 1% of the pollution? How much money would it cost to remove 1% pollution from the river? You could probably go there with some friends and maybe a couple of dump trucks or something and plug in 1 for X to represent 1%. And what would you get? 360 times 1 is 360. 100 minus 1 is 99. And 99. So remember, Jesus would leave the 99 to go find the one lost lamb. Remember that. That's why this should be in chapel. 360 divided by 99. Oops. How did I get e to the 800 630? Wow, that's okay. Hold on. 360 divided by 99. Uh-oh. It's a decimal. Okay, let me try again. Let me reduce it just the old way. Calculators sometimes are slower than doing it by hand. 360 divided by 9. 36 divided by 9 is 4. So you get 40. 99 divided by 9 is 11. It's 40 elevenths. I just made up the 9 because 9 goes into 336. I'm just trying to reduce it. So it'd take 40 elevenths million dollars to remove 1% of the whole river's pollution. So what if you passed a law? Would you like to pass a law that just says all pollution needs to be gotten rid of? Would that work? So how much would it cost to remove 100% of the pollution from the river? 360. In fact, before I do it, let me show you a graph of this. 360x over 100 minus x. Let's go to our friend desmos.com, the great. So y equals 360x over 100 minus x. And let's zoom out. So you can, hold on, let me change the axis. So the x-axis is going to go from 0 to 100. Oops, sorry, I tapped the wrong. Whoops. Hold on, sorry, my fault. 0 to 100, and the y-axis is going to go from like 0 to 1 billion. There we go, perfect. So notice that the cost of it, wait, what happened? Okay, the cost of it is really low. To get rid of 0% of the pollution, the cost of it's really low. The cost of it stays low to get rid of 40% pollution and it's still low. What happens if you try to get rid of almost 100% of the pollution? The cost goes infinitely high. So you take an infinite amount of money to so f of 100 would be 360 times 100 divided by 100 minus 0. 100, no, divided by 100 minus 100. I'm sorry. What's 100 minus 100? 0. So you'd have 36,000 divided by 0. Now, technically, that's undefined, but in this case, since you're working with positive numbers, it would actually technically, you could say it equals infinity. Although really it's undefined, but mentally we can just imagine that undefined in this case, undefined means infinity. So the price would go up to infinity to get rid of all the pollution. Does anybody have any idea why? Why is it easy to get rid of some pollution, but an infinitely expensive, it's infinitely hard to get rid of all the pollution? Pardon me? Yeah, and also the pollution dissolves and goes farther and farther away. Like, let's say if I dropped a thing of Skittles into the river, or maybe a thing of like something that would float, like a thing of flower petals into the river, I could probably pick up quickly like a few buckets of water and get most of the flower petals back, right? So I could get like 50% of them back pretty easily. But do you think could you think it'd be hard to get the very last flower petal maybe that floated away really fast? I might never be able to get the very last one back because it'd be super hard, right? And if you dissolve some chemical, like let's say if I poured a little bit of poison into the river, I could real quickly grab a bucket and pick up the bucket and get most of the poison out, but some of the poison already would have gone further. And if I tried to get more water out, some of the poison would have gone already even beyond that. So basically, you never can get all the poison out. So the reason this is related to chapel is once you do something wrong and it hurts somebody else or whatever, it hurts the world, you can never quite actually ever make up for the whole consequences of that. So that's why that there's always like ripples of bad things that happen more and more and more from anything that happens that's like something wrong. So that's why it's related to chapel. So anyway, that's number 48. So just remember that you can't ever actually get everything bad back that you've done or whatever, but you can be forgiven for it. That's what Jesus is there for, though. So 49. Let's look at number 49. Yeah, so the answer is, well, actually, we had several answers. So
That can be removed.
yeah, so we actually never really did the exact example that the book said. So let me do the exact example the book said. So it says 360x divided by 100 minus x. And we're supposed to figure out how much you can get, how much pollution you can find if you spend $120 million on the project. So if you spend $120 million on the project, and that's equal to the cost that it takes to get pollution, how do you solve that to figure out how much pollution would be found? So how much pollution would be removed? How much pollution, which is called X, is removed if you spent $120 million on removing pollution? Well, all you have to do is just take the 360x on the 100 minus x, set it equal to the cost, which is in millions of dollars. And then technically this is a fraction equal to a fraction, although it doesn't look like it though. How do I make that into a fraction and a fraction? Put it over 1, right? Now, if it's a fraction equal to fraction, how do you solve that? That easy way? Cross multiply. So do the top of the left times the bottom of the right, and then do the top of the right times the bottom of the left. There we go. Perfect. So then we distribute this. There we go. 360x equals 12000 minus 120x. And then which is smaller, the negative 120 or the positive 360? The negative 120 is a little smaller, so I'm going to get rid of that one to make it easier. Perfect. Then you get 480x equals 12,000. And then divide by 480. Wow. I'll cancel out 1 0 from it. And then I'm left with that. 1200 divided by 48. Let me reduce the 12 and the 48 by, actually 12 goes into 48. So if I divide the 12 into 48, the 12 becomes 1 and the 48 becomes 4. So then you have 100 on top and you have 4 on the bottom. Does that make sense? Because you still have the 2 zeros after the 1 on the top.
100 over the
Yep, 100 over 4, and then that's equal to 25. So the final answer is 25. Yep, 25. Perfect. By the way, what ranking is our football team now? Does anybody know?
Like sixth or fifth,
6th or 5th?
I don't know.
Because we were like 7th before I mean, our team was 7th before the game last weekend, right? 8th was 8th. Have they come out with the new rankings yet? Oh, okay. So 48, let's go to number, well, these are all actually pretty much the same. So let's go to 51. Let's go to 51 because we like area 51. Like, who knows what area 51 is? It's where the aliens live, supposedly. T over R equals Z over V. T over R equals Z over V, and we're supposed to solve it until we have the letter R by itself. So if you're a pirate, you would like this because it's like R, R, R. How do we get R by itself? Good question. Well, it's impossible. Well, Math on the Street says it's impossible. Is that right? That's not actually right. So how do I do it? Well, thankfully we have a proportionality so we can cross multiply. So, we got a TV going on. Is TV healthy or unhealthy? Unhealthy. So TV equals 2R. 2 radical if you watch TV. Now, how do we get the R by itself? It's almost by itself, but not quite. What do I have to do to get the 2 by itself? Divided by 2. So 2 cancels out, and then R is equal to TV over 2. So if you cut your TV time in half, then you'll have better results, because R stands for results. Well, then it's even easier, actually. Then you don't even have to divide it by 2. So if it has 1 over V, then you only have to divide by a number if you have a number. Okay, oh wait, actually, no, wait. It's not a 2, it's a Z. Sorry, that was my fault. I looked at it as a 2. So that's actually a Z, so mine doesn't have a number either. So that whole thing is actually supposed to be a Z. So it's actually TV over Z equals R. So divide your viewing time by Z. Actually, this means if your TV viewing time is 0, then you'll have results. So TV 0 equals results. So any questions about that? I'm just trying to like interpret the meaning of them to like be relevant. Okay, are you ready for number 52?
Yes.
So 52, it says 1 over P plus 1 over S equals 1 over B. So if you can eat 1 whole pizza, then as a student, then you are really brave. So 1 over P plus 1 over S equals 1 over B. We have to try to get B by itself. There we are. Because we want to be all that we can be. The Army's motto used to be all that you can be. Okay, perfect. But then all the students got B's, so they didn't have that motto anymore. Just kidding. So solve it for B. How do I solve it for B? Well, the technique is still the same. So let's play the jealousy game. LCD. Ready? LCD. So imagine that you know 3 friends, and one of your friends has like a Porsche, or however you say that. One of them has like what's an S car? Supra. One of them has like a Bugatti. So what would you be jealous for? You'd want to have the Porsche one, the Supra, and the Bugatti as well, right? you would want to have a P, S, A, and a B. Because you'd want it all, right? Everything that could possibly you could have that anybody else has. If you saw it, you'd want it, right? So we're going to multiply everything by the LCD. So we're going to put a PSB. Isn't there something called a PS something like PlayStation?
Yeah.
Yes.
PSB, PS2. Is there going to be a
Yeah.
PS3? What's the PS right now? PS6?
PS3 was like
PlayStation
2013.
So multiply by PSB, and then what we get? What will cancel now? What will cancel? Should I do a quick inspection?
Yeah.
Do a quick inspection. Did someone go to the side? I'm just like randomly picking stuff. Yeah, it's actually. Okay, well, I didn't detect any inappropriate activity or anything like that. By the way, have you ever heard of the show called That's So Raven?
Oh, yeah.
If you were watching that, I might actually stop and keep watching it actually. But PSB, that's the LCD, because there's one denominator with a P, one with an S, and one with a B. So if you were jealous of them, you'd want them all. So basically the LCD is PSB. Then you have to multiply every term by the LCD. So you multiply every term by PSB. Now we're ready to cancel. So what cancels from the first fraction? What cancels from the first fraction? The P's cancel. What cancels from the second fraction? The S cancels because it stands for second. And on the third fraction, P cancels because it stands for third. Then you're left with 1 times SB, like one softball player plus one baseball. Wait, it doesn't quite work, but one peanut butter equals one PlayStation. There we go. So one softball player had some peanut butter for a snack and they were playing their PlayStation. How about that? Now, how do I solve that equation? Well, first, multiply through by the 1. So 1 times SB is just S. Oh, that's spring break, actually. It'll be spring break in like 150 days, maybe. I don't even know how many. Spring break plus PB equals PS. And then how do I get B by itself? We're actually lucky because usually you're not lucky, but if you're trying to get B to be by itself, you need to get B to be on the same side, right? So we want to have the B's on the same side, but guess what? The B's are already on the same side though. By the way, has anybody ever seen the lady that's always saving the B's? There's like somebody on the internet that's like always saving the B's, like holding the B's with her hands and stuff and like says, it's a good day to save the B's. You should find that. But, so how do I get the B to be by itself? First, I make sure the B is on the same side, which it already is. And then what do I do next? I have to factor the B out. So remember, the lady who saves the B's always finds the queen B and like finds the queen B to save the queen B. So we factor out the 1B, the queen B, and then we have the S plus the P left over. And then that's equal to PS. And then what do? Divide by what's left. S plus P is equal to a number, and we just divide both sides by that number, S plus P. What will happen? So if anybody wants your number today and you don't want to give it to them, just tell them your number is S plus P. Because you learned that. So B is equal to PS over S plus P. Now, final question, can you cancel the S's and the P's to get 1 for the answer? Can you cancel the S with the S? No, because guess what? The S at the bottom is being added. It's not a common factor because something that's added isn't factored out. The one on the top is a factor because it's multiplied. So S times P is like multiplied out together. So the top one is a common factor of S, but you cannot factor the common factor of S on top with the S on the bottom because the S on the bottom is not actually a factor. Because addition, when something's added, it's not a factor. So PS over S plus P, that's the final solution. Let me just double check that it is. Yep, it is. Smart. Okay, well, now let's try to do 54 or 53. Do you feel tough or untough? Big tough falcon, right? So R equals B plus B with a bar over it. What? This is crazy. Over T. R equals a B plus B with a bar over T. They're just trying to actually make your brain hurt, that's all. The bar just means like a different letter. Like imagine if you had a 27th letter in the alphabet, like there's a regular B and then B with a little bar over it. So we're trying to solve it for B. How do we get B by itself? Well, once again, that's technically a fraction on the left if you put it over 1. So we can cross multiply because it's one fraction equal to one fraction. How do we cross multiply? We hit the top of the left. I think I'm going too slow. I think a little faster. I just realized I've been talking too much about like everything. Okay, good. I don't know, but I want to get to the alligator problem.
Try this one first.
Okay, so R times T, the bottom of the top of the left times the bottom of the right equals the top of the right. Wow, this is crazy. Times the bottom of the left. So then what do you get if you do R times T? You just get RT. What do you get if you do 1 times B plus B prime? You just get 1B, which is B, plus 1B. What did I say? B prime? It's not right. B bar. There we go. B bar. Bar. Oh yeah, bar V. That's the very best one ever. Okay. Now we have to solve for B, but remember the B with the bar over it, that's not a B. We only need to get that one by itself. So if I just subtract the B with the bar over it to the other side, RT minus B bar is equal to regular B. So I mean RT minus bar B is equal to B. So RT
I'm just following along.
minus bar B is equal to B. The bar is what's confusing because that bar is not fair because that bar, your brain doesn't know how to process that bar. But that bar is treat the bar like it's part of that letter B, except remember that B is not a B anymore because it has a bar over it. It's like a different letter.
Do you know how to put the bar over?
On the computer,
Yeah.
you might just have to select your letter and then like you can look at the tools and see if there's like a tool with a bar over it.
Do I just look up A with the bar and then copy and paste it?
We'll click on. Is that the only tool where you have?
Yeah.
Can you turn your computer on and let me look? But I'm just doing a little investigation to figure out how to do a bar above something. Oh, myself.
I
Sorry.
can look up A with the bar and then copy.
This is not a fair problem. Did anybody figure out how to get a bar?
At the bottom.
Is it the bottom?
At the bottom.
Where? Keep me pressing on. Yeah, that's what I did.
Oh, well, let me check with B. Now maybe, I mean A, sorry. Maybe if you select this first. This. That's the bottom. That's. Where did you say it was? Show me where it was. This has been stumped.
Don't press more, it's just something first. Like
First row. I'm sorry. Where is it? Where?
He's not on. What?
Oh, I found it.
You found it? Okay. I'm not even sure where to find it myself even, but.
I don't know. It's weird,
Okay, so let's go ahead to some more. Okay, let's go to a wheelchair problem. Let's go to 5.
This.
Which one is it?
I said this one.
Oh, that one.
Yeah.
That was blank.
Bar. Yeah. Bar.
It says bar, okay. It looks blank though. Okay, so 55, ready? This one says, Oh, this is actually just, this is just a visual problem. You just graph, figure out the answer. I think you can figure that one out, hopefully. Let's go to actual real problem 57. 57. Ever heard of Heinz 57 sauce? So this one says the cost is equal to a fixed cost per month, a monthly cost, in other words, of $100,000. And it costs you $200 to produce each bicycle. So remember, costs, your total costs in business are equal to your fixed cost plus cost per unit, which is $200 times X. So your cost is 100,000 plus 200X. And that's based on the fixed cost of $100,000 and the cost per unit or per bicycle of $200. So that's the first answer. Part A is just equal to that. Part B, write the average cost. Oh, now I see why they were teaching you the bar. The bar stands for average. So average cost is equal to total cost divided by total quantity, right? Because if you want to find the average of anything, you total all of it up, you divide by the total quantity, and then you get the average, right? So the total cost is equal to that number. And then the total quantity is equal to X, because X is the amount of bicycles that you make. So that's the answer to that. That was pretty easy. So in part B, the answer is just that formula. 100,000 plus 200X over X. And then it said, so this is the answer to part A, this is the answer to part B. Now we're on part C. Ready? How many bikes must be produced each month in order to have an average cost of $300 per bike? So we know the average cost has to equal $300 per bicycle. And we know the average cost, the name of average cost is called C bar. So that means we want C bar to be equal to 300. So we're going to go up to the previous equation. We're going to plug 300 into the left side. So we're going to get 300 equals the right side. This is difficult. And then this is a fraction equal to a fraction because I could put the 300 over 1, right? So how do you solve a fraction equal to a fraction? Cross multiply. So 300 times x is 300x. And now really, we don't really need to cross multiply 1 because 1 times anything is just equal to itself. So 1 times the top of the right side is just going to equal the right side again. So the top of the right side does not change. Wow, there we go. So we get that. Any questions?
Wait a second.
You know what I suddenly thought about? Every single year, the Friends University used to have a barbecue day at Everly Farms. Have you ever been to do you know what Everly Farms is? And this probably mean want to have a barbecue day.
They just mountain bikes. What is it asking for?
It's asking you to calculate the cost of the mountain bikes and then the average cost of the mountain bikes. And then it wants you to calculate when the average cost equals 300. So we're almost done with figuring out when the average cost equals 300. And I'm going to subtract the 200 first. Subtract the 200 first. The 200x, I mean, 200x. So do you think anybody's ever had 200 x's, by the way?
Right.
So 100 x's equals $100,000. Wow, that'd be a lot to pay. So x equals $100,000 divided by 100 would be $1,000. So if you have 100 x's, each x could get $1,000 each out of the 100,000. So you'd be, actually, that's not the answer. The answer, I mean, that is the answer, but that's not what it means. It's not about x's. This is about mountain bikes. So this is how many mountain bikes you'd have. You have 1,000 mountain bikes. Okay, perfect. You're doing great. By the way, how many of you are still, I should have just checked this before class though, but how far are you all into this section of homework? Do you all have like a lot left or just a little? Are you up to this point in it, most of you? Because there's only like 10 or less problems left after this. Let's go ahead and work on them some more. Ready? Are there any specific problems that you'd like for me to work on the most? Would help you out the most that you're stumped on? Are you stumped on any of them? Oh yeah, 6, 7. Wait, oh wait. Oh yeah, okay, let's do 6, 7 because of 6, 7 and stuff like that. So okay, sound intensity. Ready? Let's do it. But first, before we do it, I need to teach you about direct. So how many of you know the word variation? Variation is represented in math by the letter K. Because no matter what, basically you'll always have some variation. The variation is represented by K. Variation is represented by K. So I forgot the word represented. So if you say that sound intensity has a variation, that means that sound intensity equals K. Like that. And then there's two kinds of variation. There's direct, which is also sometimes called direct or joint variation. And then there's there's a second kind, it's really a third kind, I guess, or well, because direct and joint are basically the same as each other. And there's a third kind of variation, or a second kind really, which is called inverse variation. Direct and joint variation both mean multiply. They mean multiply. Inverse variation means divide. So variation is represented by K, direct or joint is represented by multiply, and inverse is represented by divide. So if your sound intensity has variation, that means sound intensity equals K. And then it says it varies inversely. Inversely means divide. As the square of the distance, so you put the distance squared into the bottom. So that's all that it says. Sound intensity varies inversely as the square of the distance. And then we're ready to go. HOTTOGO. It says if you are in a movie theater, so this actually is relevant to real life. Have you ever been in a movie theater? So if you go into a movie theater and you change your seat to one that is twice as far from the speakers, how does the new sound intensity compare with that of your original sound, of your original seat? So if I go to, so let's just try this out. How far away do you want to be sitting at first? Give me like an amount of feet. 20. Wow. Let's do 1.
Okay.
Just to make it easy. So the sound intensity, if you're sitting 1 foot away, would be equal to K divided by 1 squared, right? So the sound intensity would just equal K. Boom. And then let's think of the value of K. Let's just assume that K is equal to, let's assume K is equal to 1 as well. Let's assume you're 1 foot away and the amount of variation is 1. So S would equal 1. So the sound would be 1. Now let's assume that your distance changes to be twice as much, but the variation of sound is still the same. So let's assume that K stays 1, but your distance is 2. So we're going to go twice as far away as you were at first. So how much sound is there if your variation of sound is still 1, but by the way, the variation of sound is caused by like the speakers or whatever, like whatever kind of speakers you have, if it's the same brand of speakers, that'll stay the same. So it's still 1. But if your distance is 2, so I'm taking the equation S equals K over D squared. I'm plugging in the same value of K for the sound, for the K on top, still 1. For the distance, I'm plugging in 2. So what's the sound level if you go to be 2 feet away? What's 2 squared? 4. So now the sound level is 1/4. What was the sound level in the original one? 1. So how many times weaker or stronger is that? It's 1/4 as strong, but just to make sure, let's do it 2 more times. Let's try to go, okay, so let's go to the same equation again. S equals K over D squared, because you can't prove something just based on one example. So give me a different brand of speaker. Let's say you have big, powerful speakers. Let's say they were 10 times as strong. So let's say K equals 10. And let's say that in fact, let's say K equals 100 even. And let's say you were 5 feet away. Would that work? Yeah, let's say you're 5 feet away. What would the sound strength be if you're 5 feet away and the K was 100 and you're 5 feet away? What's 100 divided by 5 squared? What's 100 divided by 5 squared? 4. Okay, now let's calculate the sound again. So the sound is equal to K, which is 100, divided by D. So we're trying to figure out how much the sound would change if you went twice as far away. So what's twice as far away as a distance of 5?
Just doing the number times itself and then 1 over that.
You could, yeah, you're looking at the example probably, right?
Like that. Actually,
Well, the example actually shows a really cool way of doing it as well. But the distance, what's twice as 5? What's 2 times 5? 10. So what's 10 squared? So plug in 10 for the bottom and then square it. It's 100. What's 100 divided by 100? 1. So you get how much stronger or weaker is it? 1 compared to a 4. 1 is 1/4 as strong as a 4, right? So the sound will always become 1/4 as strong. So the answer to the problem is 1/4. So that's where we're going to stop today. And I guess I'll push the homework back a little bit more so we can finish this up on Wednesday. But I'm going to push the homework back to Wednesday night, but I'm also going to push the test back also to the same night. So yeah, so the homework on this chapter 6 is going to be due on Wednesday night. And also the test though is also due on Wednesday night. Yeah. 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 So good job, everybody. Sorry for going so slow today.
Thank you very much.
You're welcome.
Thank you.